Hello viewers, myself is Dr. Vadiraj Beetango, Assistant Professor, Sri Jagadguru Tontadariya Government First Degree College, Mundargi. In this video, it is a series of Thermoelectricity chapter. In that, it is a fourth video. And this is for BSc program, Physics subject, fourth semester, and this is for the fourth session also. Learning objectives of this session is to know the concept of thermoelectricity, to understand the differences between Peltier and Joule's heating effect, thermodynamics of Peltier effect, necessity of the Thomson effect, and Thomson effect. Session outcomes are perfect knowledge about thermoelectricity, clarity of Peltier effect, thermodynamics of Peltier effect, necessity of the Thomson effect, and Thomson effect. And prerequisites for this discussion is concept about basic terminologies of thermodynamics, concept of heat and temperature, basic laws of thermodynamics, Seebeck effect, and Peltier effect. Contents of my discussion is differences between Peltier and Joule's heating effect, thermodynamics of Peltier effect, necessity of Thomson effect, and Thomson effect. And thermoelectric phenomena, we know it is a production of current electricity from the heat due to the metals. In this phenomena, we have studied Seebeck effect, Peltier effect, and Thomson effect. So we want to list out the differences between Peltier effect and Joule-Thomson effect. Peltier effect is reversible phenomena, while Joule's heating effect is an irreversible phenomena. Peltier effect takes place only at the junctions, but Joule-Thomson effect is observed throughout the conductor. Peltier, it may be heating or cooling effect. Joule is always heating effect. Peltier effect is directly proportional to current I, that is H is proportional to IT, or H is equal to pi IT, where pi is Peltier coefficient. While Joule-Thomson effect is amount of heat is directly proportional to the square of the current, that is H is proportional to I square, that is H is equal to I square RT, where I is current, R is resistance, T is temperature. Peltier effect is, it depends upon the direction of the current. Joule is, it is independent of the direction of the current. One more is, Peltier needs two dissimilar metals. Joule needs only one metal is sufficient. So these are the differences between Peltier and Joule-Thomson effect. Now we want to study the thermodynamics of Peltier effect. So we know if you interchange the battery of the two dissimilar metals, again hot junction becomes cold and cold junction becomes hot. Hence the Peltier effect is reversible. Hence all second laws of thermodynamics, they are applicable in the case of Peltier effect. So we know Peltier coefficient is given by heat absorbed or evolved at the hot junction, and cold junction is given by pi IT, where pi is Peltier coefficient and I is electric current, T is time taking. And we know the two dissimilar metal junctions are given by like this. And hot junction we can call temperature evolved is H1, but cold junction we can call as H2. Hot junction, its temperature is T1, while cold junction is temperature is T2. And we know second law of thermodynamics as heat to its temperature is constant. Therefore, if we apply the second law of thermodynamics at hot junction, it becomes H1 upon T1 is equal to constant. Similarly, at the cold junction, H2 upon T2 must be equal to constant. Therefore, equating these two, we get H2 upon T2 is equal to H1 upon T1. If we substitute H as pi I t. Same current is flowing in both the metals in a same time. Therefore, I and T are remains constant, but Peltier coefficient, the hot junction is pi 2 and cold junction is pi 1 and is given by pi 2 divided by T2 is equal to pi 1 upon T1. And we are separating the pi's and t's, we get pi 2 upon pi 1 is equal to T2 upon T1. Subtracting 1 on both sides, pi 2 minus pi 1 divided by pi 1 is equal to T2 minus T1 divided by T1. Making pi 1 to be right side, it becomes pi 2 minus pi 1 is equal to pi 1 upon T1 into T2 minus T1. Since difference of Peltier coefficient is EMF and pi upon T, again it is a constant according to second law of thermodynamics. Therefore, EMF generated in case of Peltier effect is directly proportional to the difference of the temperature. This is the application of the second law of thermodynamics for the Peltier effect. Therefore, EMF developed in case of Peltier two dissimilar metals is directly proportional to the difference of the temperature. Hence, according to thermodynamics of the Peltier effect, the EMF generated is directly proportional to the difference of the temperature and it is linear, and if you plot the graph EMF versus temperature, the graph is linear and it is a straight line. But according to Seebeck effect, the thermo EMF applicable is parabolic curve, and we have got the equation as E is equal to AT plus BT square, and hence it is a parabolic. We have explained the neutral temperature and temperature of inversion, and therefore it is a beautiful parabolic curve. So straight line curve according to Peltier, Seebeck according to parabolic, then discrepancy has been arrived, and this discrepancy has been resolved by a famous scientist called Thomson. Therefore, name after him, that effect is called Thomson effect. And this is the necessity for the Thomson effect invention. Now, Thomson effect. When a current flows through an unequally heated conductor, there is an evolution or absorption of heat takes place, also not only at the junction but also takes place throughout the conductor. This effect is known as Thomson effect. Thomson effect is also reversible like a Peltier effect. See here, we have taken the copper rod. A and B are the two ends of the copper rod, and C is the middle point. We are heating by using Bunsen burner at the point C, and then heat will be generated and heat will be moving from C to B and C to A in equal distribution. Now, if we pass the electric current through the A point, then suddenly B point its temperature is increases while A point temperature is decreases. As a result, B becomes hot end and A becomes cold end. Therefore, it produces the two different temperatures, hot end and cold end, and this is called Thomson effect. Similarly, in case of iron also, if we pass the electric current through the A, but the phenomena is little bit change here. At the B point, we are getting cooling effect, but at the point A, it is a heating effect. So it is exactly reversed in case of positive Thomson. It is in case of copper. Therefore, copper exhibits positive Thomson effect and iron exhibits negative Thomson effect. And also, if you reverse the electric current, again the hot cold junctions they are becomes reverse, and hence Thomson effect is also called reversible effect like a Peltier effect. Hence, all laws of thermodynamics are applicable in case of Thomson effect also. Thank you very much for your such a wonderful hearing. Thank you one and all.